Hi everyone, greetings from King's College of Engineering. Myself K. Arun, Assistant Professor in Department of Civil Engineering. In this video, we are going to see how we can compare the strain energies of two shafts. What is a shaft? Shafts are usually of circular cross-section, so generally used to transmit power or torque through their rotational motion. They are also subjected to torsional shear stresses within the cross-section of the shaft, the maximum at the outer surface of the shaft. So shafts are generally of circular cross section. They are used to transmit power or torque, and they are subjected to torsional shear stresses within the cross section of the shaft. So the maximum stresses will be at the outer surface of the shaft. So what are all the types of shaft? So first one is a solid shaft. We can see a solid material, and the second one is a hollow shaft. We can see the hollow portion at the center of the shaft. So the diameter of the solid shaft is generally denoted as capital DS, and for the hollow shaft we will be having two diameter. One is the internal diameter, another one is the external diameter. So the external diameter is mentioned as capital DH, and the internal diameter is mentioned as small dh. So generally while analyzing a shaft or while we are solving a problems in shaft, we should be aware of the three formulas. So now we are going to see that. The first one is area of the solid shaft. So generally area of a circular member will be pi d square by 4. So here also we will be using the same formula, pi by 4. Here the d should be mentioned as capital DS. And similarly for a hollow shaft, the area will be pi by 4 into capital DH square minus small dh square. That is outer diameter square minus inner diameter square. Next one is volume of a shaft. So volume of material is given by area into length. So here area is pi by 4 dA square should be multiplied by length of the shaft. Similarly, volume of the hollow shaft is given by area of the hollow shaft multiplied by the length. So area of the hollow shaft is pi by 4 into capital DH square minus small dh square. It should be multiplied by the length of the shaft for calculating the volume. Next one is a strain energy of a solid shaft. It is given by the formula tau square by 4c into V. Here tau is the shear stress and c is the rigidity modulus. And strain energy of the hollow shaft is given by tau square by 4c into V. Since we are having two diameters here, we have to add the diameters also in the formula. So capital DH square plus small dh square divided by capital DH square. So strain energy of the hollow shaft is given by the formula tau square by 4c into V. It should be multiplied by the diameter, outer diameter square plus inner diameter square divided by outer diameter square. So now we are going to solve a problem. Compare the strain energies of the following two shafts subjected to a maximum shear stress. So they are given two cases. One is a hollow shaft having outer diameter n times the inner diameter, and the second one is a solid shaft. They also mentioned that masses, length and materials of the two shafts are same. So now we are going to compare the strain energies of two shafts. One is a hollow shaft, another one is a solid shaft. While mentioning the hollow shaft, they have given one condition like the outer diameter is n times the inner diameter. So now we are going to draw the diagram for better understanding. So this is hollow shaft. So it is the inner diameter small dh, and next one is the outer diameter. So outer diameter capital DH will be equal to n times the inner diameter. The next one is a solid shaft. So solid shaft diameter will be mentioned as capital DS. So this is 1 and this is 2. So now we are going to compare the strain energies of these two shafts. Now I am going to write the given data first. So the problem they have mentioned as masses, length and materials are all same for both the shafts. Hence area of the hollow shaft will be equal to area of the solid shaft. Length of the hollow shaft will be equal to length of the solid shaft, and diameter of the hollow shaft, outer diameter of the hollow shaft is equal to n times the inner diameter. So this is the condition they have given, and ds is the diameter of the solid shaft, dh is the outer diameter of the hollow shaft. Small dh is the inner diameter of the hollow shaft. Capital AS is the area of the solid shaft. Capital AH is the area of the hollow shaft. Capital US is the strain energy of the solid shaft, and UH is the strain energy of the hollow shaft. So what we have to calculate, or what we have to find, is we have to compare the strain energies and then we have to give the solution or a value. So UH is the strain energy of the hollow shaft and US is the strain energy of the solid shaft. So we are going to compare these two strain energies. So given that area of the solid shaft is equal to area of the hollow shaft, so I am starting from this. Area of the solid shaft is pi by 4 into capital D square, and area of the hollow shaft is pi by 4 into capital D square minus small d square. So I am simplifying this. Pi by 4 is common in both the cases, and then capital D square will be equal to d square minus small d square. In question they have mentioned as outer diameter of the hollow shaft is n times the inner diameter. That is, capital DH will be equal to n times the small dh. So I am substituting the value of capital DH as n dh here. So dA square will be equal to n into dh whole square. Here we should not forget that while substituting the value of dh, we should put square for n also. So most of the times the students will make a mistake here. So n dh whole square minus dh square. So on expanding this, dA square will be equal to n square dh square minus dh square. So dh square is common in both the terms. I am taking it outside. Hence, capital D square will be equal to small d square into n square minus 1. So now we have arrived a value for diameter of the solid shaft in terms of diameter of the hollow shaft, which will be useful for substituting in the later part. The next one is strain energy of the hollow shaft. So already we have seen the formula for strain energy of the hollow shaft. That is tau square by 4c into V. It should be multiplied by the outer diameter of the hollow shaft plus inner diameter of the hollow shaft square divided by square of the outer diameter of the hollow shaft. So again we are going to substitute the value of capital DH here. So instead of capital DH I am substituting n DH whole square. In the next step I am going to substitute the value for volume V. So volume of the hollow shaft will be equal to pi by 4 into capital DH square minus small d square multiplied by length of the shaft. I am going to put the value of V in the strain energy formula. So the formula may look like a lengthy one, but it is very simple. So only we are going to use the three formulas: area of the shaft, volume of the shaft, and strain energy of the shaft. So step by step solving will make it easier. So tau square by 4c. So I am substituting the value of V here. And then already I have put ndh, so I am writing the same here. So in the next step I am going to simplify this. So instead of dh, n dh, so I am directly written as n square dh square. Again here also I have expanded this. Okay. The next step I am taking dh square is common in this term. So tau square by 4c into pi by 4 into n square minus 1, it is multiplied by small dh square into L, and then here also dh square is common, I have taken it outside. So here dh square is common in both the numerator and denominator. I am cancelling it, and then I am simplifying this. So strain energy of the hollow shaft will be equal to tau square by 4c, and then I have written the pi by 4 length terms and all in one side and n square terms in the subsequent side. So n square minus 1 into n square plus 1 divided by n square multiplied by small dh square. So this is equation 1. So now we have calculated the strain energy of the hollow shaft. Next one is strain energy of the solid shaft US. So it is tau square by 4c into V. So again we are going to substitute the value of volume here. Volume of the solid shaft will be equal to area into L. So area of the solid shaft is pi by 4 into dA square. So I'm going to substitute the value of V here. US equal to tau square by 4C into pi by 4 dA square into L. Here already we have arrived the value for ds, that is diameter of the solid shaft in terms of hollow shaft diameter. So I am going to substitute that dA square equal to dH square into n minus 1. So the strain energy of the solid shaft will be tau square by 4C into pi by 4 multiplied by dH square into n square minus 1 and then multiplied by length of the shaft. So again I am simplifying it. So tau square by 4C into pi by 4 into L, and then n terms I have written separately, n square minus 1 into dH square. So this is equation 2. So now we have calculated the strain energy of the hollow shaft as well as strain energy of the solid shaft. So on comparing the equations 1 and 2, we can calculate the ratio of strain energies of the hollow shaft and the strain energies of the solid shaft. So UH by US will be equal to, first I am writing the value which you have calculated for the strain energy of the hollow shaft, tau square by 4C into pi by 4 into L, n square minus 1 into n square plus 1 multiplied by the dH square divided by n square. So it should be divided by strain energy of the solid shaft, which is equal to tau square by 4C into pi by 4 into L, n square minus 1 divided by multiplied by dH square. So now I am going to simplify this. I am going to strike out the common terms here. So tau square by 4C is common in both the cases. Similarly, pi by 4 into L is common. Okay, so I am writing the balance terms. N square minus 1 into n square plus 1 into dH square divided by n square divided by n square minus 1 multiplied by dH square. So here also we have some common terms here. N square minus 1 is common in both the cases. So I am cancelling it, and then dH square is also common. So the balance terms are n square plus 1 divided by n square. And hence the ratio of strain energy of the hollow shaft divided by the strain energy of the solid shaft will be equal to n square plus 1 divided by n square. So thus we have compared the strain energies of the hollow shaft and the solid shaft, and then we have arrived the value as n square plus 1 divided by n square. So the process is very simple. Only thing is we should know the formula for area of the solid shaft and hollow shaft, volume of the solid shaft and hollow shaft, and similarly strain energy of the hollow shaft and solid shaft. So thank you for watching this video. For more educational videos, subscribe our YouTube channel, King's College of Engineering, Punalkulam. Thank you all.